Hello, welcome to this lesson. In this video, you are going to learn how to use Cramer's rule to solve systems of linear equations. Okay, so for Cramer's rule, we use it when we have linear equations that have the same number of equations as variables. Okay, and it involves using determinants to solve for the unknown variables. So let's look at how you are going to apply Cramer's rule. Okay, so to apply Cramer's rule, okay, I'm going to solve an example using these two equations that I have here. Okay, so when you look at these two equations, you see that we have two linear equations and then we have two variables, which is x and y. So we can apply Cramer's rule to solve this system of equations. So to do this, I'm going to first of all write a coefficient matrix for this equation. Okay, so you're going to have the coefficient matrix to be d. Okay, and then that would be uh 12. Okay, 3 and then 2 minus 3. So this would be my coefficient matrix, and then you're going to generate another matrix which I name as d sub x. Okay, and this matrix, okay, what will happen is that I will take the column, okay, on the right hand side. Okay, and then that will be the first column in this matrix. We are going to have 15 and 13 here. Okay, and then you're going to have 3 and then minus 3. And then you're going to generate another matrix which we will name as d sub y, and then for this matrix too, you're going to have 12 and 2 here, and then for the second column we are going to replace it with this column here, which will be 15, 13. So we're going to have 15, 13 here. Okay, all right, so what will happen is that to find x, okay, x will be equal to the determinant of the matrix dx, okay, divided by the determinant of matrix d. Okay, and then y will be equal to the determinant of matrix dy over the determinant of matrix d. Okay, so what you're going to do is that you're going to find the determinant of all these three matrices that we generated. So let's start with matrix d. So the determinant of this matrix d, okay, will be equal to 12 times minus 3, okay, minus 2, okay, times 3. Okay, this is what you are going to have. So let's simplify this and see what you are going to get. We have 12 times minus 3, okay, minus 2 times 3. This will give us a value of minus 42. So you're going to have minus 42 here. Now let's find the determinant of matrix dx. Okay, so for this also you're going to have 15 times minus 3, okay, minus 3 times 13. Okay, so let's see what you're going to get for this also. So you have 15 times minus 3 minus 3 times 13. That also gives us a value of minus 84. Okay, so let's find the determinant of the third matrix d sub y. That will be 12 times 13, okay, minus 15 times 2. So let's simplify this to see what you are going to get. We have 12 times 13 minus 15 times 2. This will also give us uh, a value of 126. Okay, all right, so now let's find the value of x and y. So for x, okay, that will be the determinant of d sub x divided by d, the determinant of d. Okay, and then we know the determinant of d sub x to be minus that's minus 84. Okay, so we're going to have minus 84 divided by minus 42. The negatives will cancel out, and then we are going to have 84 divided by 42, and then that will give us a value of 2. So that means that x is equal to 2. So for y, we are going to have y to be equal to the determinant of d sub y divided by the determinant of d, right? The determinant of d sub y is 126, and then the determinant of d is minus 42, right? So let's simplify this and see. We have 126 divided by minus 42. This will also give us a value of what? Minus 3. This means that y is equal to what? Minus 3, and then we have x to be equal to 2. So this is how to use Cramer's rule to solve for unknown variables in system of linear equations, where the number of equations are the same as the number of what variables. So I'm going to apply this same method and then use it to solve a system of 3 linear equations. Okay, so let's look at how you're going to do that. Okay, so I have another example here where you have a system of 3 linear equations. Okay, where you have 3 variables too. So let's look at how you are going to apply Cramer's rule. So you know that with Cramer's rule, you are going to generate some matrices and then find the determinant of those matrices, right? So you are going to do the same thing here. You're going to have the first matrix, which will be matrix D. Okay, so for matrix D, you're going to have, that will be the coefficient matrix. You're going to have 1, minus 2, and 3. Okay, and then you're going to have 2, minus 1, and 3. And then you're going to have 1, 1, minus 3. Okay, then I'm going to generate another matrix which I'll name as dx1. Okay, so for dx1, the first column will be the right hand side of the equations that we're given. Okay, so I'm going to have 15, 15, minus 9. Okay, and then you're going to have minus 2, minus 1, and then 1. And then you're going to have 3, 3, minus 3. Okay, so you're going to have another matrix which will be dx2. Okay, so for this one too, the first column is going to be 1, 2, 1. Then the second column will be the right hand side, which is 15, 15, minus 9. Okay, and then you're going to have 3, 3, minus 3. And then you're going to have the last one, which will be dx3. Okay, and then that will be equal to, you're going to have 1, 2, 1, minus 2, minus 1, 1. They're going to have 15, 15, minus 9. Okay, so at this point, all you have to do is to find the determinant of all these 4 matrices. So let's look at how you're going to do this. So I'm going to teach you how to find the determinant of a 3 by 3 matrix. Okay, so to do this, I'm going to use the matrix D. So for the matrix D, we have 1, minus 2, 3. Okay, then we have 2, minus 1, 3. Then we have 1, 1, minus 3. Okay, so to find the determinant of this matrix, what I'm going to do is that I'm going to augment this matrix with the first 2 columns. Okay, so I'm going to have something like 1, 2, 1. Okay, minus 2, minus 1, 1. And then I'm going to have 3, 3, minus 3. Okay, and then I'm going to augment it with the first 2 columns. So I'm going to have 1, 2, 1 again. You're going to have minus 2, minus 1, and 1. So now you are going to solve this matrix to get the determinant. So let's look at how you are going to do this. So to do this, I'm going to consider the diagonals of this matrix, okay, from the top left side, and then I'll consider the diagonals from the bottom left side. So for the top left side, I'm going to have this to be the first diagonal. Okay, this will be the first diagonal. And then This will be the second diagonal, and then this will be the third diagonal. Okay, that's from the top left side. So let's look at the bottom left side. So for the bottom left side, so this will be my first diagonal. Okay, and then this will be my second diagonal, and then this will be my third diagonal. Okay, so now let's look at how you're going to use this to find the determinant of this matrix D. So we are going to have the determinant of D, okay, to be equal to 1. I'm taking the first diagonal, which is from the top left side. So I'm going to have 1 multiplying minus 1, okay, multiplying minus 3. Then go to the second diagonal from the top side, which will be plus minus 2, okay, multiplying 3, multiplying 1, right? And then go to the third one, that will be plus 3, okay, multiplying 2, multiplying 1. Okay, then we now look at the bottom side too. We are going to have minus 1, okay, multiplying minus 1, okay, multiplying 3. We are going to have minus 1 again, okay, multiplying 3. That's for the second diagonal from the bottom left, okay, and then multiplying 1. We are going to have minus 3, okay, multiplying 2, okay, and then multiplying minus 2, which is the last diagonal from the bottom left. So now let's simplify this and see what you are going to get. So look at the top left side first. We have 1 multiplying minus 1 multiplying minus 3, okay, plus minus 2 multiplying 3 multiplying 1. Then have plus 3 multiplying 2 multiplying 1. We're going to have that to be 3. So now let's look at the bottom left part. We have minus 1 multiplying minus 1, okay, multiplying 3. Then you have minus 1 multiplying 3 multiplying 1. Then you have minus 3 multiplying 2 multiplying minus 2. This will give us a value of minus 12. So you're going to have 3 minus 12, and then that gives us a value of what? Minus 9. So that means that the determinant of the matrix D is what? Minus 9. So we're going to do the same for matrix dx1, dx2, and then dx3. Okay. But to save time, I will do for dx1. You should also try and do it for dx2 and then dx3. So I'm going to do it for dx1. Okay. Okay. So we have the matrix to be 15, 15, minus 9, okay, and then you have minus 2, minus 1, and then 1, okay, and then you have 3, 3, minus 3, and I'm going to augment this with the first two columns. So you're going to have 15, 15, minus 9, and then you're going to have minus 2, minus 1, 1. Okay, so now let's find the determinant. So I'm going to consider the diagonals from the top left side. So you're going to have this to be the first diagonal, okay, this will be the first diagonal, and then I'm going to have this to be the second diagonal, and then have the third diagonal here. Okay, so now let's consider it from the bottom left. We're going to have this to be the first diagonal, okay, and then we have this to be the second diagonal, then this will be the third diagonal. So now let's go ahead and then find the determinant. So we are going to have the determinant of dx1, okay, to be equal to, you're going to have 15, okay, multiplying minus 1 multiplying minus 3. That's the first diagonal from the top left, and then you're going to have plus minus 2 multiplying 3, okay, multiplying minus 9. Then you're going to have plus, which is the last diagonal from the top left. You're going to have plus 3 multiplying 15, multiplying 1. Now let's look at the diagonals on the bottom left. We are going to have minus, okay, minus 9, okay, multiplying minus 1, okay, multiplying 3. They're going to have minus 1, okay, multiplying 3, multiplying 15. Okay, they are going to have minus 3, okay, multiplying 15, multiplying minus 2. So let's simplify this and see what you are going to get. So you are going to have, for the top left side, you are going to have 15 multiplying minus 1, multiplying minus 3, okay, plus minus 2, multiplying 3, multiplying minus 9, and then you're going to have plus 3 multiplying 15 multiplying 1. That gives a value of 144. Okay, so now let's look at the bottom left diagonals too. So you have minus 9, multiplying minus 1, multiplying 3, minus 1, multiplying 3, multiplying 15, minus 3, multiplying 15, multiplying minus 2. This will give us a value of minus 162. Alright, so let's do this. You have 144 minus 162. That will give us a value of minus 18. So that means that the determinant of dx1 is what? Minus 8. Okay, so you're able to find the determinant for d and then dx1. So you are going to use the same method, okay, to find the determinant for ds2 and then ds3. If you know how to use your calculator too, you can use it to make things fast, but if you don't take care, you might lose some marks. Okay, so when you find the determinant of dx2, okay, which is that dx2, okay, you're supposed to get 18, okay, and then the determinant of dx3, okay, that should give you a value of minus 27. Okay, so with all these values, we can find x1, x2, and then x3. So you're going to have x1 to be equal to d, that will be to be equal to the determinant of dx1, okay, by the determinant of d, right? So we know the determinant of x1 to be minus 18, okay, and then the determinant of d to be minus 9, right? So you're going to have 18 divided by 9, and then that will give us a value of 2. So that means that what x1 is equal to 2. So for x2 also, you're going to have the determinant of dx2, okay, over the determinant of d, right? So we know that the determinant of ds2 will be 18, and then the determinant of d is what? Minus 9, right? So we're going to get 18 divided by minus 9. That gives us what? Minus 2, which means that x2 is equal to what? Minus 2. Then we're going to have x3 to be equal to the determinant of dx3 over the determinant of d, right? Then we know that the determinant of dx3 was minus 27. So I'm going to have minus 27 divided by minus 9. The negatives will cancel out. Okay, so I'm going to have 27 divided by 9, and then that will give us a value of what? 3. That means that what? x3 is equal to what? 3. So this is how to use Cramer's rule to solve system of what? Linear equations, where the number of equations are the same as what? The number of what? Variables.